Hello everyone, welcome back. So in this session, we will discuss about transport layer. The transport layer is fourth layer of OSI model. In last session, we discussed application layer, presentation layer, and session layer. Okay. So now we will discuss transport layer. So what is the transport layer responsibility? The transport layer responsibility is to transport data. To transport data. Transporting data. See here. Transport layer provides reliable and unreliable services. Reliable and unreliable services. What is the reliable and what is unreliable? Reliable means guarantee delivery. Unreliable means no guarantee. So transport layer provides both reliable services and unreliable services. Reliable services means guarantee delivery and unreliable means no guarantee delivery. In transport layer, there are two protocols. TCP and UDP. These are the transport layer protocol. Very, very important. TCP and UDP. These two are transport protocols. But what is the difference between these two, TCP and UDP? TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol. Transmission Control Protocol, User Datagram Protocol. TCP provides reliable services. See here, the transport layer provides reliable and unreliable, right? But who provides reliable services? TCP protocol. TCP protocol provides reliable services. UDP protocol provides unreliable services. Unreliable services. Unreliable means no guarantee. Means we will not receive any acknowledgement after sending data. Reliable means you will receive acknowledgement after sending data. TCP is also known as connection oriented protocol. This point is very, very important in the interview. TCP is also known as connection oriented protocol and UDP is also known as connectionless protocol. Connection oriented protocol and connectionless protocol. Connection oriented means what? Connectionless means what? This point is very, very important. We need to understand this point very clearly. Okay, now I will explain in whiteboard. So now here connection oriented, right? So this is PC and it is connected to Wi-Fi router and it is connected to internet. It is my Wi-Fi. And here we have a server, Facebook server 1.2.3.4. This is Facebook. Now 192.168.1. Here www.facebook.com. So when I enter this in browser, either you can use Google Chrome or you can use Mozilla Firefox, you can use Microsoft Edge, any browser. So when you enter this, system will not send this request to server immediately. The first system will establish TCP connection. TCP connection. So here, the first here between client, this is the client PC, between the client and the server, these two, client and server, both, okay, will both establish TCP connection before sending data. Before sending this data to server, first client and server should perform what? TCP connection. How these two perform TCP connection? TCP connection is nothing but what here? Virtual session, virtual connection. Between the client and server, one virtual connection would be established before sending this data. But how these two establish this connection? So now here to establish this connection, client PC will initiate TCP three-way handshaking. Remember this point, very, very important. To establish virtual connection, TCP connection between client and server, the first client PC will initiate the TCP three-way handshake. What is the TCP three-way handshake? Three-way handshaking nothing but the first client PC sends one message to server. The message is SYN message. Which message? SYN message. Client and server. Client sends SYN message to server, which means client is asking, a server, I want to connect with you, like that. Then if server is ready, if server is available, server sends server SYN plus acknowledgement. Server sends SYN plus acknowledgement. SYN means synchronization. Acknowledgement means what? Server is telling client, hey client, I have received your synchronization packet. Okay, I want to also connect with you, like that. So SYN plus acknowledgement. The finally client sends one more message, that is acknowledgement. Okay, server, I have received your SYN message. Okay, we will connect both of you, like that. So this is TCP three-way handshaking. This TCP three-way handshaking is very, very, very important. Once this TCP three-way handshaking is successfully completed, then client PC sends this data. If TCP three-way handshaking is not successfully completed, this client PC will not send data. Remember this point. Very, very important. For example, client has sent SYN message, but server is not sending SYN plus acknowledgement due to any network issue. Then what happen? Our system will not connect server. So what is the use of this TCP three-way handshaking? First of all, why TCP three-way handshaking is required here? Why TCP three-way handshaking is mandatory? The first thing is here, client PC will get to know whether server is available or not, right? The first client PC sends SYN message. This SYN message means small message, like, hey server, I want to connect with you, like that. If server is there, server responds, right? If server is not there, which means what? Client understand, oh, server is not available, so I should not send any data to server, like that. So immediately it will ignore the data. That is the one advantage. That is the one purpose. What is the next purpose? One more purpose is there. One more purpose is here. The main purpose is, the second purpose is the most important purpose. Here what happened? Okay. For example, this is the client PC. This is my PC. Okay. For example, this is my PC. My PC is 192.168.1.2. I connected to internet, and there is one server. This is Toronto, for example, Toronto server. So here there is one file. The file size is 1 GB size. Okay, and I am sitting in the Hyderabad location. So one more user is there. One more user means he is in the Bangalore location, and he is also using the internet. One more person is there, Chennai location. So here different users, different locations. So these three users are accessing this file, 1 GB file. These three users are downloading this file. Here this is my PC, right? I am using internet speed is 50 Mbps. My internet speed is 50 Mbps, and this user using 20 Mbps internet, and this user using 100 Mbps. And server side internet is 1 Gbps, very high speed server side, and server hardware is also very high CPU and very high memory here. Now these three users are trying to download this file, 1 GB file from torrent site. So first what happened here, these three computers will establish one TCP connection. So here to here there is one TCP connection. Here to here there is a one TCP connection, and here to here also we have a one TCP connection. After completing this TCP connection, then data would be exchanged, right? Okay. So now what happened here? The server is server side internet speed is very high, 1 Gbps. And here these three users are using the different speeds. For example, when these three users sending request to server, okay, sending request to server to access this 1 GB data. In case if server is sending this data at 1 Gbps speed to these three employees, what happened? If server is sending this data 1 Gbps speed at 1 Gbps speed to here, what happened? These systems can handle that much of data. The system can receive that data? No, right? Because of here 20 Mbps. 20 Mbps means what? 20 MB per second. Here 50 Mbps per second. 100 Mbps, 100 MB per second. So these systems can handle only, this system can handle only 20 MB, this system can handle only 50 MB, this system can handle only 100 MB. If server is sending data at 1 Gbps, these systems cannot handle. This is the problem. But how the server will get to know how much should I send data to requesters, senders, like receivers, requesters? How this server will know? So here what happened during this TCP three-way handshaking? During this TCP three-way handshaking, okay, during TCP three-way handshaking, client and server will negotiate some parameters. Remember this one, very important. During TCP three-way handshaking, client and server will negotiate some parameters. What are the parameters? The first one is the first one is window size, and the second one MSS, the third one selective acknowledgement. These three parameters are exchanged during the TCP three-way handshaking. This is the main purpose of TCP three-way handshaking. Why TCP three-way handshaking required here? Client and server should understand how much data we can receive and how much data can should I transmit. So these two, server and client, can negotiate, can understand the capability of them, right? So this is the main advantage of the TCP three-way handshaking. So here window size. What is the window size? I will explain briefly here. Okay. Window size. Window size means buffer size. Means receiver buffer size. How much data can store here? For example, this PC sending TCP sync packet, right? The first packet is the TCP sync packet. In the TCP sync packet, this client PC will send the window size. Means, hey server, my window size is the default one is 65,536 bytes. Okay, it is dynamic. It is not a fixed. Okay, it is a dynamic. It will keep on changing. Okay, server client PC tells server, hey server, my window size means my buffer size. My buffer size is 65,536 bytes. So I can store this much of data in my buffer. Okay, but at a time, if you send this much of data at a time, I can't. This is my available space in my my PC. But how much you should send at a time? MSS, maximum segment size. What is the maximum segment size? The default one is a 1460 bytes. What? 1460 bytes. This is the maximum size. So you should send data per packet 1460 bytes only. But I can receive this much of data. I can receive and I can store this much of data, but at a time not possible. At a time you should send only 1460 bytes data. That is MSS, maximum segment size. Window size is what? Window size is nothing but total buffer space, buffer size. How much system can store. Okay, what is the MSS? So MSS describes how much server should send data. Both will negotiate these parameters, not only server. Client will sends these three parameters server also sends these three parameters clients. So accordingly, client and server will exchange the data. Next one is what? Selective acknowledgement. Selective acknowledgement means whether it's support or not. So every packet it sends the acknowledgement, right? Whenever packet is lost, it will send the acknowledgement. These three parameters are exchanged during the TCP three-way handshaking. This is main purpose of TCP three-way handshake. TCP can send large amount of data. We can send data 1 GB data, we can send data 2 GB data, we can send 3 GB data, we can send 4 GB data. But at a time not possible. So TCP will break this data into small bits. For example, I am sending hi, how are you? This is data. The first TCP break this data into small pieces like this. Hi is one packet, how is one, R is one, U is one. This is called what? Segmentation. What? Segmentation. First to TCP perform segmentation. TCP perform segmentation. The first data would be segments. Then it will assign sequence numbers. 1, 2, 3, 4. This is the first segment, second segment, third segment, fourth segment. For each segment, it will assign sequence number. So then what happen? After segmenting this data, it will send the first segment to server. Server receives, server will send the acknowledgement. Then it will send second segment. Again acknowledgement. Next it will send the third segment. If in case, if a client is not receiving acknowledgement, then what happen? Again it will resend one more time, same packet, same segment, third segment again. This is called reliable. TCP perform segmentation, but in UDP, no segmentation. In UDP, no handshaking process. UDP, the purpose is to send small data, small amount of data. UDP can carry the data size is up to 512 bytes only. Very small. If you want to send data more than 512, UDP does not support. We should use TCP. Remember this point. This is the main difference between TCP and UDP. TCP. TCP is very slow protocol compared to UDP. UDP is fast protocol compared to TCP. Now see here. TCP. And TCP supports only unicast communication. Unicast communication. Unicast communication means one-to-one communication, point-to-point communication. TCP supports only unicast communication. But UDP supports unicast communication, broadcast communication, and multicast communication. Unicast, broadcast, and multicast. And TCP protocol number 6, UDP protocol number 17. Remember this protocol number, very, very important in interview. TCP protocol number is 6, UDP protocol number is 17. These are transport protocols. These port numbers are very, very important. Protocol numbers, not a port numbers. Protocol number. TCP protocol number is 6, UDP protocol number is 17. But how, when to use TCP and when to use UDP? This is depends on application. Okay, we don't decide. Okay, TCP and UDP. We can't select this TCP and UDP. When we are sending data, we can't select TCP and UDP. This TCP and UDP are based on the applications. Applications means what here? In application layer, we already discussed, right? In application layer, we have different applications: HTTP, HTTPS, and FTP, DNS, DHCP, Telnet, TFTP, SMTP, and SSH. These all are the applications. So here some applications use TCP and some applications use UDP. Here HTTP and HTTPS. These two use TCP. When you open browser and when you type www facebook.com or cisco.com, what happened? The first this HTTP protocol like a contact TCP. TCP will perform TCP three-way handshaking. So this is based on the application. Some applications are depend on the TCP and some applications depend on UDP protocol. When application engineer develop this application, that time the application engineer will programmed like this TCP or UDP. Remember this point. We can't select automatically when we are sending data. There is no any option to select TCP or UDP. This is completely depends on UDP application. So some applications use TCP and some applications use UDP. And next thing, the next important thing is in transport layer, port numbers. Port numbers are very important. Port number is different, protocol number is different. Protocol numbers are used to identify the protocols. Port numbers are used to identify the applications. Remember this point. Applications are these applications, right? HTTP, HTTPS, FTP, DNS, DSCP, Telnet, TFTP, SMTP. These are applications. But actually here, system identify these applications based on port number, based on service number. System does not understand what is the HTTP, what is the HTTPS. System identify these applications based on the port number only. Okay. So here total port numbers are 1,265,535. Total port numbers are 1,265,535. In this range, 1 to 1023 are well-known port numbers. Well-known port numbers means familiar port numbers, server port numbers. These all are 1 to 1023 are server port numbers, familiar port numbers like FTP, DNS, DSCP. These are well-known. These applications are well-known applications. Well-known means everywhere in the world use same port numbers. FTP, for example, FTP port number is what here? See, 2021, right? So everyone use only these port numbers only. Well-known. And after 1024 to 49151 are registered port numbers. Some companies register these port numbers. Some applications are like proprietary applications. Like a Cisco company develops some applications. Microsoft company develops some applications. So they use some port numbers. They register some port numbers here in this range. And remaining ports are client port numbers. 491522, 65,535 are client port numbers. Client port number means system will automatically generate. System will automatically generate those port numbers. Next point. See here, applications. Applications are FTP. FTP is one application. And FTP use port number 20 and 21. 20 is the server port number, 21 is the client port number. Remember this point. And FTP application depends on TCP. It is very important. You should know both. Okay, whenever you are whenever you are going to learn application, you should know what is the port number and you should know what is the protocol, transport protocol. So FTP application depends on TCP protocol. And FTP port numbers are 20, 21. 20 is server, FTP server, 21 is FTP client. And next, HTTP. HTTP is port number is 80 and transport protocol is TCP. These port numbers are also very important in the interview. So whatever I mention here, these ports are very important in the interview point of view. Interview mostly ask from these port numbers only. These all are common port number for every organization, irrespective of domain. Any company, either it is software company, either it is banking sector, either it is pharma sector, any company use these applications. That's why these port numbers are very, very important. Please remember these port numbers. So these are very, very important in an interview point of view. HTTP port number is 80 and HTTP depends on TCP protocol, and HTTPS port number is 443 and it depends on TCP, and DNS port number is 53 and depends on TCP and UDP. We will discuss these applications here later. Okay, so what is the purpose of these applications? We will discuss some applications in CCNA and some applications not part of the CCNA. Okay, we will discuss DNS, we will discuss DSCP, we will discuss telnet, we will discuss HHH. Okay, we will discuss these all protocols. Okay, right, remember these port numbers: SSH 22 TCP, telnet 23 TCP, SMTP 25 TCP, SNMP 161 UDP. Like this, we should keep in your mind. This is about transport layer. Now what happened here? Now what happened here? The transport layer, what happened? So now user, right? So this is PC. The PC IP address is 192.168.1.2 and this is connected to Wi-Fi. It is connected to internet. In the internet we have a Facebook, right? So now here user open browser and user type www.facebook.com, www.facebook.com. This is data. This is application data. Which application data? HTTP data, because browser uses HTTP, right? So that's why it is called what? HTTP data. HTTP data, or we can also say payload. Payload. Payload means what? Actual data. So then what happened? This data would be added to in the transport layer. This is the data, right? Who prepared this data? Browser. Browser protocol is what? HTTP protocol, right? So HTTP depends on which protocol? TCP, right? So here what happened? This data would be added to TCP header. TCP header. Here we have source port number and destination port number. Source port number, destination port number. Remember this point, very, very important. Source port number is random number. After 1024 you can use any port number, because up to 1023 are well-known port numbers. And what is the destination port number? Destination port number is 443, because browser use which protocol? Browser use HTTPS. See here, I will open one browser. For example, here cisco.com. Enter. See, I got what? HTTPS. And what is the HTTPS port number? See here, HTTPS port number is 443 and it is a TCP. So what happened here? Here the first data, the data would be added to TCP. This is called encapsulation. Remember this point. This process is called encapsulation. Encapsulation means adding headers. The first two system prepare data and the data is encapsulated into TCP header. Encapsulating means what? Adding headers. Encapsulation means what? Adding headers. The process of adding headers, that is called encapsulation. Okay, so this transport layer creates this. This is called segment. This is called what? Segment. Remember this point. Transport layer creates segments. Transport layer creates segment. Segment is nothing but what? Segment is nothing but application data plus TCP header, or depends on application. Right? It depends on application. We can have either TCP header or UDP header. So transport layer creates segments. Remember this point, very, very important, that the transport layer creates segments. Application layer creates application data, and then transport layer add TCP header. Then it will become segment. We cannot see presentation layer and we cannot see session layer. Very, very important, this TCP, this flow, these headers. Okay, so this is the responsibility of transport layer. So in next session, we will discuss about the last three layers: network layer, data link layer, and the physical layer. And if you have any doubt here, please ask me, and you can also send in comment. Okay, Q&A section. Okay, so okay, we will meet again in the next session.